Swayam Prabha. Digital India. Educated India.
Welcome to the NPTEL online certification course on structural systems in architecture, and we are in the last module today, and this is the 8th module, and this module will be on the spatial structures. And in this module, the first lecture will be on the temporary structure, that is in continuation the 36th lecture. So, in this lecture we will going to cover some of the concept of temporary structure. We will start with the tensegrity and then we will discuss the pneumatic structure, then we will go to the floating structure and the folding structure, and the last one is definitely not a temporary structure, but we will discuss a bit of the cost effective technology, and in that we will discuss the filler slab and what is the structural advantage and how the economy can bring on this particular cost effective building technology. So, in the learning objective of today's discussion will be, we will discuss the structural principles and the applications of the various temporary structure. The outline gives you the kind of how you can apply and which are the domain area that you can apply that particular structural principles, and we will going to outline the filler slab technology at the end as a part of the cost effective building technology. So, let us start with the tensegrity. Tensegrity is one of the, I must say, it is one of the fundamental kind of a structure, even though this was eventually came little late in 1960s, but it is one of the very fundamental kind of a structural systems. This tensegrity is means that it is a special kind of a arrangement where the tensile and the compressive forces are actually neutralized with each other, and it will be act as a tensile integrity in that format, and from that only the tensegrity, that word came. So, in this structural principle, if you see in the tensegrity, you have a system of isolated compression member or discrete compression member. So, the compression members are discrete, it is it's in the various part of a particular body, and which will be wrapped by a continuous network of tension. So, it is something like, it is not like a truss. Truss is, if you see, truss is also a, I mean, some of the members are of tension and some of the members are in compression, but there is not such a cases, or maybe there may be a few cases only where you will get the whole it is the network of the tension is actually taken care of by the compression. No, it may be the haphazard kind of a thing, but here it will get, you will get a kind of a network of tension which can taken care of by discrete compression member. So, one of the simple example is this, where you see this post or this kind of a sticks are of compression member, and definitely you need a hard or tough member for compression member, and those members are have to be prone for buckling and all. Usually it will be bar or stud, and that will be actually tied down or with a network kind of a thing, with a kind of a rope or maybe kind of a cable can be also thought of to make the pre-stressed tensile network, which will be actually neutralize the compressive force also. So, we cannot replace with each other. Suppose we replace the compression by the stud or by, or maybe the tension by the cable, the compression by the cable, that cannot be occurred, because the cable cannot take the compression, whereas the stud, if you give, that will be a discrete kind of a thing, that continuity of the tensegrity will not be there if you replace the cable by the stud. So, now who actually is a father figure of this particular kind of a concept? He is none other than the master architect and the philosopher of this modern the architectural era, a lot of the mathematical and the innovative structural systems the designer, the Buckminster Fuller 1960 initiated or initially has given a kind of a thought on this particular type of structural system. See the photograph where a particular various small studs and that is compression studs is actually taken into a whole lot of the tensile cable. So, sometimes it is also called as a island of compression in a sea of tension kind of a thing. This particular concept was if you want to see that particular tensegrity concept, how it will going to happening, and then we have to see that there are some sets of compression element. Suppose in the left hand side photograph you can see. So, those are the compression element. So, those are the compression elements. So, there is a compression forces if you take the free body. So, those are the compression elements are there, which actually wrapped with the tensile element, which are those studs or sorry which are those cables, those are taking tension, and these two, tension and the compression force, are opposed and balanced with each other. That is the final the mathematics or maybe the balance of the forces has to be taken into account. That is the most important part of that. So, then you need to know that how many studs will be required to form this particular geometry, and how many links like the tie will required for to deneutralized or oppose this particular kind of a forces. And not only that, what will be the inclination, the 3-dimensional inclination of all those compression studs and the tensile cables has to be actually has to be there in the 3-dimensional plane, and that is also very important. So, after you do that, after you thought of that, you required a kind of internal systems of pre-stressing and the stabilization of the entire structure, which will going to simultaneously happen, as I told that if you can know that particular force, how much is created and how it is going to pre-stressed with the tensile forces also in a particular 3-dimensional angle. This tensegrity still yet to come into in the form of a the stable structural systems used by the architects. There are very few examples that are that is using as a architect as a structural systems in architecture, but modern days it is actually act as some kind of a pavilion design, or maybe this particular gentleman Kenneth Snensland, who is actually the disciple of the Buckminster Fuller, and he himself has created lot many of those kind of a structural the elements in a modern art gallery in form of that, and it is demonstrated the constructive art form through the tensegrity. So, in USA there are a lot of universities, and in a park his installations are there, which is basically based on the tensegrity. This is one of those picture, those are his work. So, those are all you see, it is the tensile, the wrapping forces, which will be actually taken care of discrete compressive studs. This is one of his famous work, Snelson's work. It is called the Needle Tower. You see, it is the kind of the ceiling view, the left side one, and this is the actual the isomer or the photograph of that, gradually diminishing. Things are floating, this kind of a floating tension also sometimes it is known as the tensile things are wrapping the floating studs, which are under compression. Now, this is one of the example of course, which is there in Brisbane, Australia. It has been used as a small river bridge, the tensegrity structure. In structural behavior point of view, the members are loaded either in pure compression or the pure tension, as you understand, and the pre-stressed tension cable allows the whole system to maintain a structural integrity. That is the wrapping, and those are that is particular gives you the particular the integrity on that particular system. And then the structure becomes stronger as it is loaded, because it will share the load like that. Due to the configuration of the structural element, no member experience bending moment and the shear force, as it is play with the compression and tension only. We will go to the pneumatic structure now. Pneumatic structure is a kind of a tensile or membrane structure. We have discussed the last week only the tensile and membrane structure. So, it is one of those type, but there is slight difference in this system of pneumatic structure. The air is used, the air pressure is used, and it is something like a balloon kind of a structure, or so. It is internal pressure of this air has to actually one of the component of the support system. The high air, which is more than the atmospheric pressure, is create that kind of a envelope of the system, particularly the roof envelope of the structure, and there is a kind of a airlock doors and all these things has to be maintained, because otherwise the internal pressure will drop down and it will not going to sustain the form. The supportive structure required has to definitely will be there to maintain that particular continuity in the pressure, and the structural is finally anchored to the ground, and finally it is transmitting load to the foundations also. Every action is taken for any kind type of air leakage also. So, if you classify the pneumatic structures, there are first you can say there are two major way you can classify. The first one you can classify as it is a air supported pneumatic structure or air inflated pneumatic structure. It is based on how this air is actually going to use to support the system. And the second way of classification, you may say it is a high profile or low profile pneumatic structure. This high or low profile pneumatic structure is based on the parameters like the height to span ratio, how much is the height to span ratio, and the connectivity of the total roof structure or this particular form with the foundation, whether it is directly connected or indirectly connected also, and the load distribution pattern. So, let us discuss some of this four first. The air supported the pneumatic structure are that the air is introduced inside, it is actually like a balloon. So, it is kind of a the air is pressurized, air is put inside that particular single layer flexible membrane. If you please note down this particular word, single layer, the membrane, and under that high pressure situation, this flexible membrane are inflated and give the particular shape, something like a kind of a balloon. And this membrane definitely will produce tensile stresses. This tensile stress will be stabilized by the cable systems and all supporting cable system, and finally the cable system attached to the finally in the ground. So, this is one of the examples. So, this is the single layer system. So, somehow you put some kind of the air in, so that high pressure air in, so that this particular system is inflated. In the right hand side you see one of the photograph of that kind of a balloon kind of a thing, and that can be act as a the air supported pneumatic structure. Now, the air inflated pneumatic structure are similar, but there is slight difference as the air is going to be handled. Air is introduced in double layer flexible membrane. Initially the first one we have seen that is a single layer, but here is a double layer. So, the air is actually pushed into this double layer kind of a system, and which is definitely above than the atmospheric pressure, and this stiffener member or metallic plate and all has to be provided in the specific locations as you require the form. So, if there is a kind of a saddle kind of a ridged, so those particular form can be created by stiffener member. Under this high air pressure, flexible membranes and the stiffener positions inflated to give a particular shape, and the double layer membrane produce the tensile stress. So, here actually you do not need to put the air inside that particular habitat area. The in between the double layers the membrane you have to put those high pressure air. So, it is used for the roof covering, otherwise it can be finally the tensile stresses that is created by is stabilized by supporting cable, and finally that can be taken into the foundation system. So, this is the fundamental. So, you have two layer, both the layers, and in between the layer, this is layer number 1 and layer number 2. So, in between the layer you insert the air and that going to be inflated. So, the something like that. Some of the our home there are some the kids are sometime using those kind of items for their day to day play item as a play item. So, it create a kind of a, and as you know in this particular figure, if you see there are some ribs, these are the stiffeners, and because of this arrangement of the stiffener there is a ups and down and the undulations and those kind of a form is generated, and this is the example of the air inflated system. The high profile pneumatic systems are those, it is a freestanding structure, as I discussed earlier that it is going to have that how it is supported. So, if the earlier picture, if you see this picture, it is a high tensile kind of high profile pneumatic structure, because it is freestanding from the top to bottom the roof, and finally it is standing by itself. It is small in size, the cover membrane connected to the foundation system, and it is whole system is integrated by the bulky voluminous kind of a individual building form. But the low profile systems are for high span, when the span is very high, but it's the total the system is very smaller, but the span is very high. So, mostly used for the roof covering only. So, you have your wall system, you have your all the column everything, but only to cover the roof you require a kind of a air inflated or air supported system, or maybe in a stadium you just give this particular part, that only the top part the system like this system low profile system. So, then this particular system is called as a low profile system. So, it will distribute the load, and there is a it is not directly connected to the foundation, it is connected to the some pillars or some other type of structural systems that will take care of the load transmission. The component, if you see the component of the pneumatic structure, there are cover member, there are supporting cable, cover membrane that I have already discussed, that is give you the form, supporting cables will give you the stabilization of the tensile forces, ground anchorage systems will actually it act as a foundation or transmit the load to the foundation actually, and the air pressure and ventilation system is required, because you need to create that particular pressure continuously. So, this is a kind of a plan and elevation of a particular air inflated kind of a system, and there are some stabilizing arch as a cable that will be there, there will be the membrane, fabric membrane, and there are emergency exit must be there. There are some kind of the airlock rotational or the revolving doors, and then there is airlock, because for movement there should not be any loss of the air, I mean in between people are moving here and there. So, there should not be any loss on pressure, and definitely a inflation system will be supporting the particular structure. So, advantages is that it is a lightweight, it is supported wide span, it can be the cost is construction is very low, it is very quickly can be constructed, erected, the structure is safe, it is very lightweight. So, if any kind of a damage or any kind of a fall on this structure, nothing will going to happen. The pneumatic roof can allow good amount of daylight, that is also one of the important point. The pneumatic structure is best fit of course for the short time use, and that is why it is a come under the temporary structure. Disadvantages also there, the pneumatic structure cannot take live load, because you know it is only the wind, some normal wind and all these things it can take. And the profile of pneumatic structure mostly curvilinear, so it can be used for the single floor application, you cannot have multi floors application on that. It can't withstand the high wind load, and it is relatively short in life. The application areas are huge, you can use in the sports arena, recreation center, the emergency disaster management application. Suppose there is a disaster and you need to quickly reallocate people for a kind of a duration for 2-3 months. So, for a rehabilitation kind of a camp, you can think of that, you can erect very quickly and all. Military structure, you can use it for the storage or medicine storage purpose. Greenhouse for horticulture kind of a thing, botanical gardens, zoological park, exhibitions, a lot of areas just for temporary structure. You can use it for the survey camps also for some 4, 5 or 1 week. Now, next is the floating structure, that is also sometimes used in our application areas whenever in demand. So, it is has some kind of a specific requirement, then only we can go for those kind of a structure. These structural principles are that it has a floating foundation system. So, it can be float in definitely in water, and the superstructure load has to be balanced by the buoyancy. The superstructure should be light in weight, and reduction in the live load is required, because as live load if it is increased, then there will be a problem of that particular buoyancy or those kind of a balance system. The float control adjustment, mechanical adjustment should be also adopted in this particular structure. So, this is one of the conceptual drawing I have made for that. So, in the plan if you see, those are the first if you see, those are the cylindrical air filled cylindrical floats, a lot of floats. It has to make a matrix kind of a thing, and you have to put it one after another, make a kind of a base, and over the base you have to put the deck. This is the first and this is the second, you have to put the deck. So, you have a kind of a horizontal kind of a platform. So, this is the 2. So, you know this particular float will going to float, it has a buoyancy which is on, it will going to float, and then the deck, and then over that you can put your third one, that is the building. This is the building. So, it comprises of this 3 system, the float and the floating foundation, the deck and the superstructure, but if you just remove that, the particular the building will flow from one point to another point. So, you need a kind of mechanical control. So, you have a grip. So, mechanical movement control grip will be there in the 4 corner or the strategic location. You sometimes may require in the central point also if it is required. So, those are the kind of a barrier which will actually penetrate till the depth of the water or the particular the bed of the river, and that will be give you a kind of a control. That is one of the system, one of the way you can thought of. Another way you can thought of, if there is suppose there are kind of a tide or this kind of a the system is, you can think of a kind of system when there is a the level of the water is ups and downs, then we can also have some kind of a cylindrical air cylindrical floats which is long and which is can be put into 2 or 3 tires in fact, and there are internal the arrangement to make that kind of in an integrated way. And over that, this green one is the deck, this green color, this thing is the deck, where it is in blue color, and the building can be done. So, it's the thing is that it is having kind of the integrated kind of a the system which is having the cylindrical kind of a float. Cylindrical floats are both ends has to be definitely I mean the closed, and that can be very lightweight material like plastic, PVC, or maybe very thin metals maybe. And this is the movement control pillar. So, when if there is a change in water level, suppose the water level is till this, so it will float and this will going to restrict your movement till the top. So, you are here, you are at this particular point, and suppose the water level goes down. So, now the water level here, so it is go down, and this things will the building will move down because of that particular level changes and all. So, and this can be very much adopted in any kind of the situation driven kind of a areas. So, the application areas of the floating structure are it can be used in the housing in the waterlogged area, the housing in the flood prone area. That is one of the important area people can be think to provide this kind of a solutions for the flood prone area, where maybe once in a 2 year there are floods. So, they lost their the houses, and there are a lot of loss in the housing infrastructure. So, we can think of those kind of houses. The water sports and recreation areas, we can think of military structure, there are some requirement, and emergency disaster management applications in case of some disaster happen in the nearby area where there is a water or maybe the river and all those kind of thing, the bank of river also, there can be some kind of a shelter maybe thought of with this kind of a floating kind of a structure. Next one, let us discuss the folding structure. The folding structures are, again it is sometimes many a times it is driven by the requirement also. So, if you require sometimes it is this kind of a structure, you go for that. The folding structure are applicable for the specific requirement, and it is mostly mobile kind of a structure. So, from one place to another place it can move, that is one of the requirement of this folding structure. And this type of structure are constructed in small scale, because it is required to transport it from one place to other. The structural principles, if you say the structural principles require some adaptation of mechanical arrangement, because it will be fold, it will be actually pushed, there will be kind of a play in this particular the component of the wall component, or maybe the ceiling component, or maybe the floor component of the building, or this particular small miniature form of the building. So, you require lot of hinges, lot of slides, those kind of mechanical arrangement. The second one is the superstructure has to be lightweight, because that is required, because otherwise movement will be very tough. I mean, it is not be easy to move one part of the portion to the other part, and fixing and all those things will be very tough if it is not lightweight. And also lightweight is required because it is a mostly mobile structure. So, if it is lightweight, then the cost of mobility or the cost of transportation will less or easy. And it should be modular in type, because you may require many modules in some spaces because of the requirement, and maybe somewhere you require a small number. So, as number vary, the demand vary. So, it is better to go with a modular type of a construction, or the structural principles also has to be formulated with that can support the modular type. The spatial design consideration should take place the transportation of the structure, as I told you, because you have to see the size. If you are going to transport through some trawler or lorry, so you have to actually see the what is the dimension of the trawler, or maybe the small lorry or whatever. So, the dimension of your final folded form should be such a way that it can actually I mean, you can actually keep those particular folded form in a transportation vehicles or so. So, that is also very important. So, suppose I have a folding form. So, suppose this is the folding form is that, and if I just want to open it. So, I suppose these are the one of the modular forms, say suppose one module. So, I can, as demand suggested, so I may transport 5 module, 50 module, whatever. So, from that folding form I can transport to the site, and then I have to expand it. Okay, expanded form is first expanded form. So, just push these 4 corners in the 4 point. So, there should be some kind of a rail or something like that, and then this particular the blue color lines, 3 lines are there in all corner. That is nothing but the folding sliding kind of a something like a folding sliding kind of a panel. So, it create finally a wall, it kind of a wall is created. This is actually the wall member. So, you can have the wall in 4 sides, and these dotted lines in blue in green, that is your floor systems, or that also comes under the modular 4 pieces or so. So, based on that you can have your the fixing of those 4 pieces, or maybe those kind of a folded things can also be act as a ceiling or the floor. So, this is one module. Now, we can make the replication of this module twice, 2, 3 as required for this particular purpose. So, this is another type of suppose folding form. So, this is suppose if I see this is one of the form. So, if it is folded form, so it is very compressed. Now, I have to take it to the first open it up. So, I create a deck projection. So, this is actually going to be projected as a deck, these two are projected as a deck. Then we go for the side wall opening up. So, this is going to be give you the side wall opening up, and then this third one, this one will be actually the central box can be created. So, it is a sectional. Now, this is, please remember that one is in plan and this is section. So, you can have a maybe the 1, 2, 1, 3 spaces creating like a the folding manner. So, the application of the folding structure are the roadside shops. You have seen lot of roadside shops are folded structure and mobile structure. Also, the medical assistance in the rural areas. So, suppose you take a ambulance with some medical assistance and then you create the ambulance such a way the back portion of the ambulance open up and there are foldings, and this can create a kind of a large area, quite a large area. So, some one doctor or some patient and some nurses, also some beds will be there. So, for the regular checkup. So, those kind of medical assistance rural for the in rural areas, you can thought of those kind of a the folding ambulance kind of a thing. Then the temporary structure in fair or public gatherings, some kind of a fair pavilion or something like a some booth in the this thing. Movable toilets, that is also required in the fair or any kind of a public gathering in time of the Kumbh Mela or maybe in time of the Ratha Yatra in Orissa, Puri. So, those are the big event for the public gatherings or so, and we can actually think of those kind of movable toilets, because toilet is in those areas it is need, but it can be again transported to some other area whenever there is a need. Or so the emergency disaster management applications also it can be easily accommodated. Now, finally, with a little glimpse of the filler slab cost effective technology. As you know, in slab construction or any kind of a RCC construction, if you see, this is the neutral axis will lie, it is a flexural member. So, it is come under the bending. So, the neutral axis is there at the central point, and the above the neutral axis concretes are very good in compression, but and concrete can take care of the compression also, but in the below the neutral axis the concrete is poor in tension. So, that is why we put steel in the bottom and steel take the tension. Concrete plays no role in the below the neutral axis. So, unnecessary we put the concrete because of to make a continuity. So, in the filler slab, in that area the target is that we can use the some kind of the filler material in tensile zone. We remove the some of the portion of the concrete, we stay with the tensile steel, and the top of the portion, the neutral axis, we can put the as it is, there is no change in the concrete zone. Above the neutral axis concrete is there, below neutral axis tensile area concrete is replaced by tiles or some kind of a material which is can filler material. Lorry Baker, the famous architect who worked in Kerala for lot of low cost on the cost effective housing technology, he has developed this particular technique and it is adopted very well throughout. So, those are the some of the construction site details which can be seen as some, you can use some kind of earthen pots and sometimes tiles and all for those kind of a thing, and the ceiling view will also very nice, look very nice. So, that is all for today, this particular lecture. So, in that conclusion I must say that the pneumatic floating folding structure are essential for various requirement and application oriented, and these are the they are designed as a temporary structure, and the filler slab can provide a cost effective solutions. Thank you very much.